AMD is starting to round out its RX 5000 series of GPUs, having started at the middle and planning to work its way outward. The newest addition to AMD's family of GPUs is the RX 5500 XT, following the previously announced OEM model RX 5500 non-XT and DIY available 5700 XT and 5700 cards. The 5500 XT has 4GB and 8GB options available with MSRP at $160 and $200 respectively, putting it in most direct competition with the 1650 Super at $160. We'll test 3 models of 5500 XT today, including thermals, VBIOS programming, gaming performance, VRAM differences in capacity, and noise. Before that, this video is brought to you by the Thermaltake Core P3. The Core P3 is one of the most versatile cases on the market. It includes wall mounting hardware if a showcase is what you're after, but it can also run as a standing or horizontal test bench, making it highly accessible for modifying and overclocking hardware. The case includes tempered glass and an open-air layout for easy management and high visibility, offering a truly unique chassis for enthusiasts. Learn more at the link in the description below. So, first of all, let me apologize. I'm extremely sick right now. It happened right in the beginning of this review cycle. I'm going to apologize if I'm a bit nasally in this review. I'm going to do my best. We have a lot of data to go through, though. The 5500 XT card still runs on the same Navi architecture. It still uses 7nm manufacturing process, but it cuts down some other features. The die size, obviously, is one of the areas where cost savings come out because it's 158mm squared versus the original 5700 XT die of 251mm squared. And that reduces manufacturing costs significantly. It improves the yield, which also reduces manufacturing costs significantly because you're throwing away fewer dies for less silicon for the product. And ultimately, the result is increased yield for a smaller die. Other than that, notable differences include a reduction to 22 compute units, each containing the usual 64 stream processors. You multiply it out, compute units times stream processor, or times 64 gives you total stream processor count. The 5700 XT, for comparison, had 40 compute units, and AMD is still sticking with its painfully bad naming convention here for the clocks as game clock and boost clock, with game clock presumably going with its game cache, which is honestly probably one of the worst decisions AMD has ever made for anything relating to product marketing, because that was for Ryzen 3000 launch, which didn't need marketing help. They didn't need to do the, we're trying to relate to gamers by renaming something that's been in existence for decades as something else with the word game in it. Anyway, well, cache has been in existence for decades anyway. L3 is a bit more recent, but L3 was renamed game cache, but the game clock thing, let's just redefine back to what people are used to. This is not news. This has been around since Navi came out, but when AMD says game clock, what they mean is the traditional interpretation of boost clock. And when they say boost clock, what they mean is peak opportunistic boost, which can happen for as little as 1 millisecond. So basically, the boost clock, we can ignore both these numbers because we're working with partner models today that have potentially done some tuning in VBIOS. We'll talk about all of that as we go through the review. And a couple of other things to talk about before we really get into stuff. The cards, it's rated for 130 watt for board power budget, and the cards can, of course, tweak their power budget afforded to the GPU by VBIOS, and that's done based on the board partner and if they have a good enough VRM to accompany it. So we'll talk about the power budget of the Powercolor Red Dragon we're reviewing and of the Sapphire Pulse we're reviewing. Then we also have 8 and 4GB models of the Pulse to look at as well. And finally, a note on overclocking. We're going to show some results in the charts for the 4GB Sapphire Pulse that are bad. And the reason we've included those is because they are overclock results. But with overclocking specifically on AMD, in general you should do this, but specifically on AMD, you really need to validate your results as you increase the clocks, because what will happen is it'll look like you have a much higher stable clock than you actually do, because the bigger numbers will apply and they'll potentially hold. It might not crash, you might not get the black screens and catastrophic failures you get with NVIDIA, but actually you kind of would prefer to have those failures because it tells you, hey, this stuff's not working. Whereas with these cards, typically what will happen is you push and push and push, and you end up with an unstable setting. Now with the 5500 XT 4GB model, we spent about half a day, about 6 hours on it, overclocking it, and we're never able to get it to improve beyond stock by any measure that was worth mentioning at all. it was typically 1 to 2 FPS at maximum delta, not even positive, just different from the stock results. And then we included some of the results where it's bad when overclocked, specifically to illustrate why you need to validate your results and not just tell everyone on the internet what you set and how great it is, because it might not actually be working. Anyway, that's just a note for you. Let's get into the testing data. We've got a lot of games, thermals, and more, and then we'll talk conclusions. Before we do any comparisons between the 8GB and 4GB models later, we need to make sure they're running at roughly the same frequency, as any differences here would potentially invalidate testing that attempts to isolate memory capacity. During standardized frequency testing in a reproduced frame of Firestrike Extreme, we measured the 8GB Sapphire RX 5500 XT Pulse at about 1835 to 1840 MHz average, with peaks at about 1850 MHz. The 4GB model averaged slightly higher, around 1840 to 1845 MHz, and peaked at about 1856 MHz. Given that our difference between these two is typically about 5 to 7 MHz point to point, we're close enough that these are basically identical. We're more on the lookout for numbers closer to 15 to 25 MHz or greater. A 5 to 7 MHz gap won't meaningfully contribute to performance differences, and so these two can be fairly compared in head-to-head tests as an attempt to isolate for memory differences without needing to do any tweaking to the core clock, which is good because AMD's drivers are still terrible to work with for any kind of frequency changes. We intentionally zoomed this scale to 1800 to 1900 MHz so that the difference is easier to see and extremely exaggerated, so keep in mind that we have blown out the scale of this intentionally, although we typically like to start at 0. Let's get into some thermal tests. We have a lot of these, but we'll start with the comparative between Powercolor and Sapphire for their 8GB models, just because this is typically what differentiates one card from the next. It's not actual gaming performance. Those are all going to be about the same for frame rate, and you'll see that today, but it's more about the quality of life differences and the noise at a given temperature. For the Red Dragon versus the Sapphire 5500 XT Pulse, with the Pulse set to its 130 watt default VBIOS called OC VBIOS, and the Red Dragon set to its only 130 watt VBIOS, so we're normalized for power, which is important as well, the two cards plot as follows. The Powercolor Red Dragon at 40 dBA plots a GPU edge temperature of about 57 degrees Celsius, with the Pulse's 40 dBA edge temperature at about 59 degrees for the target at 40 dBA. This has more to do with how the VBIOSes set their fan thermal response more than anything else, but because we've eliminated the fan part of that, we're able to better see how the thermal response is. If you're just running stock, all you're really looking at is what number did they set their temperature target to. You're not really testing much else. Junction temperature matters much more though, and we see the Pulse at about 76 degrees Celsius versus the 80 degrees Celsius of the Red Dragon. This is outside of error or variance, but also is not a tremendous difference. Thus far, the Pulse is faring better at the same noise levels. As far as GDDR6 thermals, we'll just throw that on the screen really quickly. They're basically the same between the two cards. There's no difference. This doesn't affect the decision making at all. This chart shows the fan thermal response under full stock conditions. Both the Pulse and the Red Dragon run extremely low fan speeds, averaging about 32 to 34 dBA at our standard 20-inch distance when under stock settings, which is really quiet and low speed. This is the advantage of two comparatively good coolers when matched with a relatively low power consumption GPU. The Pulse and the Red Dragon were good with the 5700 XTs, the 5700 non-XTs, and they're both good with the 5500 XTs as well. And that just scales even better when the GPU doesn't consume as much power as the previous model. So the Pulse spins up to about 1100 RPM to maintain a 70 degree edge temperature, with the Red Dragon spinning at 1300 RPM to maintain about a 63 to 65 degree edge temperature. Both are below 34 dBA. For the GPU core power budget pre-configured for each card's VBIOS, the Sapphire Pulse Silent VBIOS targets 120 watts, shown on this chart, allowing it a reduction to better control for noise by reducing fan speeds with that extra thermal allowance from reduced power. Meanwhile, the OC VBIOS runs about 130 to 135 watts, and the Powercolor Red Dragon VBIOS does about 130 watts fixed. We're getting into games now. We'll start with our usual of Sniper Elite 4, which we like because it's so consistent and predictable. It's allowed us to build up a mountain of data for this particular game because it doesn't really change much. We'll move to more modern games after this and then add a couple of DX11 games at the end. For Sniper Elite 4 at 1080p, the RX 5500 XT 8GB GPUs, both the Powercolor and Sapphire versions of these cards, end up at about 101 to 102 FPS average. The 4GB Pulse lands at 102 to 103 FPS average, which is well within test variants and equivalent to the 8GB models. There's no difference between them. You cannot state there's a difference. It's all within error. Frame time consistency, as illustrated by 1% and 0.1% lows, though we'll have frame time plots for this in other games later, are also equal between the two cards. There is no difference. You should just buy the 4GB model and not waste money on the 8GB model in this scenario. The 1650 Super, meanwhile, is outperformed marginally by the 5500 XT when both are stock at 100 FPS average versus 101 to 102 FPS average. This difference is definitely not noticeable, and frame time pacing is also equivalent between them. Overclocking the 1650 Super got it to 105 FPS average, and overclocking the 5500 XT cards got them to 107 to 108 FPS average. And in this game, the overclock held a bit better than the others for the 5500 XT 4GB model. Shadow of the Tomb Raider is next on the list, using DirectX 12 and tested at both 1080p and 1440p. At 1080p, the RX 5500 XT 8GB Pulse ran at about 70 FPS average, with lows at 61 FPS 1% and 59 FPS 0.1%. Compared to the 5500 XT's 4GB 63 FPS average, we actually did see meaningful uplift in this title to the tune of about 11%. Overclocking the 5500 XT 4GB was a frustrating waste of time in general, but in this title we see part of the reason why. In a best case scenario, it did nothing, while the more typical worst case scenario was performance degradation because of instability. As for whether the 8GB model would be worth it over the 4GB model, the average FPS uplift is less important at this pricing delta than the frame time delta, where we see frame time consistency plummet with the 4GB 5500 XT. That said, despite a meaningful uplift at a $200 price target for 8GB versus the 1650 Super 4GB 160 availability for equivalent performance, we'd have to give overall victory to the 1650 Super in this benchmark. Note further that we, as you'll see later, did not really see this 4 versus 8GB disparity in almost any other title. It's mostly exclusive to Tomb Raider, and otherwise the difference is more clock bound on the core or core resource bound, not memory capacity bound. NVIDIA's memory compression may be giving it an edge here. The 5500 XT doesn't offer meaningful frame time performance uplift either, and is nearing the wider error margins for frame time measurements at these naturally lower sample count metrics when compared to the 1650 Super. Overclocking the 1650 Super puts it at 75 FPS average, while overclocking the 5500 XT 8GB puts it at 74 FPS average. The two are the same. We need more data from other games before drawing firm conclusions here as to who's doing best, but we'll look at some frame time data first. And just before that, Powercolor 5500 XT 8GB Red Dragon also did about 70 FPS average stock, performing equivalently in all ways to the 5500 XT 8GB Pulse. For this frame time plot, we'll be comparing the 5500 XT 4GB, 8GB, and 1650 Super models to each other at 1080p. This is the best run of 4 from each device. The RX 5500 XT 8GB is fairly consistent from start to finish, with frame times ranging from clusters around 12 to 14 milliseconds at the start of the test to 15 milliseconds in the middle and approaching 16 milliseconds at the end. Remember, lower frame times are better and more consistent frame times are best. The plot shows performance frame to frame and is the best illustration possible of the base metric of performance, which is time, rather than the abstraction that FPS is. The 5500 XT 4GB model encounters a couple of large frame time spikes visible to the user as stutters or hitches. The worst is an excursion to about 34 milliseconds for a single frame versus the previous frame's time of about 18 milliseconds. This happens again to a lesser degree later and seems to be mostly exclusive to our Shadow of the Tomb Raider tests, whereas the 4GB and 8GB models showed no meaningful difference elsewhere. We'd assume NVIDIA's memory compression and comparatively reduced architectural dependency on bandwidth leads to this delta, but we were able to reproduce the results on the 4GB model. The 1650 Super, meanwhile, mostly matches the 5500 XT 8GB card and can be seen as functionally the same in performance. There's no perceptible difference between these two in this benchmark. At 1440p, the 5500 XT 8GB Pulse lands at 47 FPS average, not bad considering this isn't really the target resolution for the card, and the 5500 XT 4GB model does about 44 FPS. The 5500 XT 4GB OC hinders performance as a result of poor stability and, frankly, poor overclocking software, and so we'd advise against wasting your time in most instances. The 1650 Super stock GPU runs 46.5 FPS average, with lows functionally equivalent with the 5500 XT 8GB. Overclocking the 8GB 5500 XT and the 1650 Super tie them at about 50 FPS average. The Powercolor Red Dragon 5500 XT 8GB ended up at 47 FPS average, again the same as the Sapphire Pulse when both are stock. Strange Brigade is next. We originally introduced this benchmark for Vulkan versus DirectX 12 comparisons, but after finding they were nearly identical in most instances, we've moved away from the Vulkan testing to just DX12. You can watch some of our initial tests from the 5700 XT or the 20 series refreshes for more detail on this if you're curious. The 5500 XT 8GB model for the Sapphire Pulse and the 5500 XT 4GB model were identical and within test variants in this benchmark. And at least this test, there is no value added from the extra $40 spent on the 8GB model. The Powercolor 5500 XT and Sapphire 5500 XT 8GB models both run at about 65 FPS average, and so are the same. Thermals and noise are more of a differentiator than outright performance here, as always has been the case with the partner models for the 5000 series so far. Overclocking gains us nearly nothing, with 2 to 3 FPS being the best we saw while maintaining stability with AMD's frail overclocking support in its drivers. The 4GB model again proved a waste of time to overclock given its performance regression on frame times. As for the 1650 Super, the stock card runs 62 FPS average, with the overclock also not worthwhile in this title at 64 FPS average, although at least it works predictably. The 1650 Super allows the 5500 XT 4GB stock card a lead of about 4.6%. This isn't particularly perceptible in this title, but is a noteworthy gain for the same priced 4GB 5500 XT that puts it in an advantageous position against the 1650 Super. Hitman 2 is another DirectX 12 title that we can look at that's relatively recent. For this one at 1080p, the RX 5500 XT 4GB and 8GB models both run at about 72 FPS average, with lows unchanged between them. This puts them at roughly RX 590 Fatboy levels of performance, and a bit ahead of the RX 580 8GB card previously. The 5500 XT overclock, the successful of the two, noting that we left the failure on here for illustration, runs at 76 FPS average, or an uplift of about 4.8% over stock. The 1650 Super runs natively at 76.8 FPS average in this title, with lows about the same as the 5500 XT cards, and overclocking allows it to get to 82 FPS average. At 1440p, the RX 5500 XT 4GB ends up at 49 FPS average. 0.1% lows, as always, are a complete mess in this title for DX12, so we remove them. The 5500 XT 8GB model does 50 FPS average when stock on the Red Dragon, or about the same with the Pulse. There's no meaningful difference between the 8GB and 4GB 5500 XT cards, even at 1440p, where they're strained a lot more. So once again, you shouldn't waste your money on the more expensive of the two, at least for this game. The GTX 1650 Super manages 52 FPS average, allowing it to outperform the stock 5500 XT cards in an overall imperceptible but measurable way. Overclocking places it at 54 FPS average, allowing the 1660 Super stock card still a lead of 13% in this title. For point of reference, the RX 5700 Red Dragon runs at 77 FPS average here, allowing it a lead over the 5500 XT 4 or 8GB models by about 52%. The price jump, obviously, is also large, but that extra performance class puts you in more 1440p or even 4K ready scenarios. Moving now from the newer titles to the oldest title, just for a balance with some DX11 benchmarking, we see GTA 5 at 1080p has the RX 5500 XT 4GB and 8GB models, including both Powercolor and Sapphire, all roughly equivalent at 83 to 84 FPS average. We're within test variants. Lows are also roughly equal at a reliable 55 FPS 0.1%. The 1650 Super finds itself in the same cluster, albeit with slightly lower 0.1% frame time consistency at 45 FPS rather than 55 FPS. For this title, if judging strictly between the 4GB and 8GB 5500 XT cards, there's no value added by spending the extra money on the 8GB model. As for overclocking, the 5500 XT 8GB ends up at 87 FPS average when overclocked, whereas the 1650 Super ends up at about 89 FPS average. At 1440p, the 5500 XT and 1650 Super alike prove relatively capable of playing this older game with our higher graphics configuration. If you wanted to play older games like GTA 5 at 1440p, it's completely doable on these modern $160 video cards. The 5500 XT 4GB and 8GB cards are roughly equivalent again, and just in case you really did want to play games like this, dropping anti-aliasing, for example, down to 0 would allow you to get over 60 FPS in a title like this one. So 5500 XT is doing reasonably here, but for an 8GB, do not prove any different in this one. Another slightly older title on our bench is F1 2018, using DirectX 11 and generally playable settings on most hardware. At 1080p, the RX 5500 XT 8GB model by Powercolor and by Sapphire both do about 79 to 80 FPS average, with the 4GB model nearly identical in every measure of performance. There's not only no meaningful difference between these two memory capacities, but also no measurable one. You'd be better off skipping the 8GB SKU. It doesn't make sense at the price and provides no value in this game. As for the 1650 Super, its performance runs slightly higher and averages at 83, although NVIDIA cards have always had an issue in our testing with F1 2018, where their frame time consistency is spotty for 0.1% lows in this title, exposing a disadvantage in this particular bench. At 1440p, the RX 5500 XT 4GB model ended up at 62 FPS average, with the 8GB option at 0.1 FPS different. That's test variance, once again, and lows are also within variance. The two are the same. The 1650 Super slightly outperforms both at 63 FPS average, although the delta is not perceptible to any human player. Powercolor's 5500 XT 8GB falls within the same performance range, with an overclock on the 5500 XT 8GB offering a couple of percentage points increase, and an overclock on the 1650 Super pushing it just past the 5500 XT 8GB OC. Overall, these cards are all roughly the same and don't offer a meaningful difference in feel of the game. The 4GB overclock again proved to be fruitless, and dropping it further only produced similar issues or a complete lack of uplift. So even with lower results, it just did, or lower frequency targets, it just didn't matter. So to really recap things quickly here, we think you should mostly skip the 8GB model, and if considering the 5500 XT at all, you can probably just focus on the 4GB model. It's cheaper by a lot, actually, at this price range. That's a significant percentage of the total cost, and it's also functionally the same performance in nearly everything we tested. Now, there are probably going to be games, we did run into one of them, but there are probably going to be games where it matters a bit more. At 1080p though, on average, you're not typically going to be running into a VRAM limitation when you're talking about 4GB as your minimum. So we really think you should mostly skip the 8GB model, kind of like when the RX 570 launched. If you don't recall, we recommended everyone skip the 8GB model there and go for 4, because it got you basically all the performance. You could even overclock it and get pretty damn close to a stock 580. So same situation here, where the 4GB model compared to the 8GB model is extremely good. It's $40 cheaper, and if anything, AMD launching 2 versions of this has made their cheaper option look significantly better by providing a relative comparison with the $40 more expensive option from 160 to 200 that has mostly the same performance, but technically not always, but it's really damn close. So that's how that pans out. The 1660 Super would probably be the next worthwhile step up if you want to spend a bit more money and get more guaranteed 1440p playable performance in pretty much every game. Then the 1660 Super would be our recommendation for you. It's not a massive jump from the $200 5500 XT. It provides a meaningful performance uplift. It gets you into another class of resolution. If you want to spend less, you should be looking at the 1650 Super or the 5500 XT 4GB, both at $160. And they're cheaper cards, but it's not really particularly worth stepping down from there. You might want to consider used if you're trying to spend less than $160 right now. Performance is overall okay. The 5500 XT is kind of a meh product. It's not something we're really mad about at all, and it's not something we're really excited about. It's just fine. And that's kind of what you expect in this price class. That's not a bad thing. It just means that it doesn't really rock the boat a whole lot. You get 1650 super performance from an alternative, from a competitor, and you can pick between the two based on other features, or if you have some strange bad allegiance to a company, which you shouldn't have, and you should cast that away. But that's really the main thing here, is you get an alternative, and they're about the same performance. Now, the problem we have with AMD for this card, AMD has done a lot. They've put a whole lot of makeup on their driver, and it looks great. Visually, they've done a lot of things to make it look like the new dynamic Web 3.0 or whatever style of driver package, which is partly cool, except for that really annoying sound effect it makes. But it's good to see, and AMD, to its credit, does and has had some of the best options in its drivers for a while. NVIDIA, for example, deserves a whole lot of, I don't know what, we'll call it scorn, for killing Shadowplay and its usefulness by requiring and mandating that you log into GeForce Experience with an account. AMD really makes up for it with Relive, where Relive works great, and it has fewer requirements in that regard, less telemetry. The problems I have with this, 2 years or more now, AMD has been unable to fix its fan profiling. I've been complaining about it since Vega Frontier Edition, and I'm sorry if this is old for you, but it's still going on, and AMD, damn it, you need to fix it. If you have a feature in your drivers, it needs to work. If it's not going to work, don't put it in there. Don't make me think that the things in your drivers will always work, because then I'm going to spend 6 hours trying to make them work, but actually it never will. It's not possible in some instances. Whether this is a problem with the board partners conforming to your API or a problem with your API and software itself is irrelevant. The problem is that the fan profiling still doesn't work at least half of the time, if not more, across all of the 5000 series models we've tested. And your board partners blame you, AMD, and I'm sure AMD will blame the board partners, and I'm sure AMD's fans will defend it for some inexplicable reason, despite the fact that we've said AMD has a lot of good products right now. It also has a lot of things it needs to keep fixing. So the problems mostly stem from overclocking. The overclocking feature set in AMD's drivers is still partially broken. We could probably just do a whole live stream demonstrating how it's broken to save everyone the time. Fan profiling, the fan still gets stuck at the higher fan RPMs. When you set them, you have to reboot or wait upwards of about 10 minutes to get it to restore back to where it was. So if we set, for example, a fan RPM of 80% and we run a test and we want to set the next one at 50% because maybe 80% is too loud, we don't like it anymore, you basically have to reboot or just walk away from the computer and come back 10 plus minutes later and maybe it'll return to where you've set it. So working up is fine. If you go from 50 to 80, it responds instantly. If you go from 80 to 50, it doesn't respond at all in a lot of instances. So it's some weird software issue. But that said, I'm going to have to, again, reiterate that the hardware is actually fine, and it's very competitive with the 1650 Super. It's a fair alternative. If you prefer to buy it, absolutely go ahead. You're not really losing a whole lot, and in some instances, you gain a bit. So the card, the GPU, is fine. We don't mind it. I'm sure the AMD people, the fans, can freak out in the comments about me, again, not liking the drivers, but frankly, they're a problem. And if you really like AMD that much, you should also want them to fix it, because then I'll stop complaining about it for every review we do. Anyway, oh, also one more thing. Sometimes in software like GPU-Z or other third-party software, which is typically extremely reliable, you'll see the fan speed percentage reported as over 100%. It's actually not possible for the fans to be overclocked. So what that really means is that it's off by about 20%. We found the offset. So the fan RPM will be accurately read. I double-checked it with a physical tachometer, but the percentage reported will be wrong. So AMD drivers will report like 40, for example. GPU-Z, other stuff might report 56 or 60 something. And that's just something you need to be aware of. Doesn't really affect functionality. Just, I don't know, just trust the RPM number, not the percentage. That's all I can give you there. Anyway, card's fine. Software still needs improvement despite AMD's massive fanfare about their new version. Please, AMD, let's make everyone's job easier here. Thanks for watching. Subscribe for more. Go to store.gamersnexus.net to help us out directly, or patreon.com/gamersnexus. I'll see you all next time.